In this tutorial, we're looking at sector area and arc length again, but this time we're using it not to find the sector area or the arc length, but to find one of the other things that we have in this formula. So it might be that you're asked to find the angle, that's quite common, or you might even be asked to find the radius or diameter. So we need to know how to use these two formulas to find other things other than just the sector area and arc length. So first thing we're just going to look at is a way to just quickly rearrange this so that we can use these more easily to find other things. So here we've got sector area equals theta over 360 times pi r squared, which we know is our sector area formula. If we were to divide both sides by pi r squared, we'd have sector area over pi r squared equals angle over 360. Now, this is quite a good formula, like arrangement of the formula, sorry, to be able to find other things. So we're just going to look at this time. And same with arc length, maybe you can try it yourself. If we've got arc length equals theta over 360 times pi d, we could rearrange it by dividing by pi d on both sides and have arc length over pi d equals 360. And we can use these in this form a little bit like how we use the sine rule. So let's look at an example. This says a sector of a circle with radius 6 centimeters is shown opposite. Angle AOB equals x degrees. If the exact area of the sector is 4 pi square centimeters, calculate the sides of the angle marked x. So we've been given a sector area. So we're going to write down our sector area formula. So I'm going to use it the way we've learnt it. So sector area equals theta over 360 times pi r squared. What we're looking for this time is the angle. So I'm just going to quickly divide, as I said before, by pi r squared on both sides. Angle over 360. Now, we want this here, the theta, we want the angle, and we've got the sector area, and we've got the radius, so, and we know what 360 is. So we're going to just rewrite this, we're going to flip them round to the other side. So instead of saying sector area equals pi r over pi r squared equals theta over 360, I'm just going to write them the other way around by writing theta over 360 equals sector area, pi, sector area over pi r squared. All I've done is just flip those sides there. This looks similar now to how we use the sine rule. Let's just substitute in with what we've got. Theta over 360 equals sector area, which we've been told in the question, sector area is 4 pi over pi times 6 squared. Theta actually in this case is x, so I'm just going to write down x here. So to get x or theta by itself, we multiply both sides by 360. So x equals 4 pi over 6 squared is 36, so 36 pi times 360. Now we can use our calculators. It could actually be a non-calculator question as well. Let's do it non-calculator. So x equals, or degrees, equals pi, there they can cancel each other out, 4 over 36, divide the top and the bottom by 4, and you've got 1/9 of 360. Then we know that the angle, 1/9 of 360, divide that by 9, 9 goes into 36, 4 times 0, 40 degrees. So we've got x equals 40 degrees, and that was a non-calculator one as well. Let's have a look at a past paper question. So here we've got the diagram below shows part of the circle, centre O. The radius of the circle is 6.4 centimetres. Major arc AB has a length 31.5 centimetres. Calculate the size of the angle. So we're calculating the size of the angle. This time we've been told the arc length, so we're going to use the arc length formula. Arc length equals theta over 360 multiplied by pi d. Just dividing by pi d on both sides, arc length equals pi d, arc length over pi d equals angle over 360. And I just want to write that the other way around because it's the angle that I'm looking for. Theta over 360 equals the arc length over pi d. Alright, so now we've got theta, which is what we're looking for, over 360 equals, arc length is 31.5, so we're going to put 31.5 there. over pi times, the radius is 6.4, so the diameter is going to be 12.8. And then last little line, angle will equal 31.5 over pi times 12.8. We've had to multiply by 360, so we're going to do that on this side as well. And then you can get your answer. So we're going to use the calculator this time. 31.5 over 12.8 pi, I'm just writing it in as, but you could also write pi times 12.8 times 360. So 282.002 dot dot dot. So I'm just going to round that to 282 degrees. And that's you. So we've used the formula. We're really just changing the subject to theta here from this original formula, or to the angle, so that we can get that answer. Okay, I'm going to look at another example of finding an angle, and then I'm going to do one example of finding one of the lengths. So this says here, pendulum travels along an arc of a circle, centre C. So this must be our pendulum here, and it's swinging from side to side along this arc. The length of the arc is 20 centimetres. So already the length of the pendulum, is 20 centimetres. A pendulum swings from A to B. The length of the arc, this is our length of the arc, is AB is 28.6 centimetres. So these words here, length of the arc, we're already thinking we're going to use the arc length formula. Find the angle through which the pendulum swings from A to B. So let's write down, we know we're going to be using arc length. So arc length equals theta over 360 times pi d. We're not actually finding the arc length, we're finding the angle. So we're going to rearrange it like we did before, just to make it a bit easier. Arc length divided by pi d, because we're just dividing by pi d on both sides, equals angle over 360, theta over 360. Swap them round so that we've got theta on the side we want it to be. Theta over 360, equals arc length over pi d. And then let's substitute in what we've got. So we have arc length, so theta over 360 is going to stay like that, because angle is what we don't know. Arc length, we've been told, is 28.6 over pi times the diameter. So if the radius is 20 centimetres, we can see this here. So we have to imagine the whole circle. The diameter would be 40. And last little step, theta, make a mistake, theta equals 28.6 over pi times 40 multiplied by 360, because we're multiplying by 360 on both sides. And then you can find the angle, 28.6 over 40 pi, pi times 40 if you prefer, times 360. We've got an angle equals 81.932 dot dot dot. So our angle here is 81.9 degrees. And that's you. Okay, last one I'm going to do is just a little bit different, because it's actually finding a length, the length of the pendulum. So it's similar in some ways. Pendulum of a clock swings along an arc of a circle, centre O. The pendulum swings through an angle of 65 degrees, travelling from A to B. The length of the arc AB is 28.4 centimetres. Calculate the length of the pendulum. So the length of the arc, so our clue again, we're going to use arc length one more time. So arc length arc length equals theta over 360 times pi times diameter. So calculate the length of the pendulum. Let's actually work out what the length of the pendulum is in terms of our formula. The length of the pendulum, if we imagine the whole circle, the length of the pendulum is the radius. From this here, we've got our arc length formula. If we work out what the diameter is, then we can work out what the radius is. So we want to change the subject of the formula here to diameter. So as before, I want us just to divide both sides by pi d, and you'll see why in just a second. So arc length over pi d equals theta over 360. Now, in sine rule, we've used this before. If we know that a over sine a equals b over sine b, we can flip them upside down and do sine b over b equals sine a over a. Here you can do exactly the same. So we're just going to flip these upside down. So pi d over arc length equals 360 over theta. So we're getting a little bit closer to getting the diameter by itself. First of all, we want to multiply both sides by the arc length because we're dividing by that there. So multiply by arc length on both sides. So pi d equals 360 over theta multiplied by the arc length. So we can either write it at the side, multiplied by the arc length, or we can actually write it on the numerator. So multiplied by the arc length. Final thing, divide it by pi. So 360 arc length over angle, also divided by pi. So we've got divided by pi. All right, so we've now got diameter. So diameter equals 360 times the arc length, which is 28.4. 360 times 28.4 over theta, which is the angle, 65 degrees, over 65 pi. Diameter equals 360 times 28.4 over 65 pi. We've got our answer, 50.067 dot dot dot. And we're going to round that to diameter equals 50.1 centimetres. Not quite the end because we're actually looking for the length of the pendulum, which is the radius. So the length of the pendulum is 50.1 divided by 2, which is going to be 25.05 centimetres. And that's you just rearranging to get D as the subject of the formula so that we can then find the radius. If this bit you weren't so sure of, I would actually look over changing the subject as well, so you can watch the tutorial on that to help changing the subject from our original formula. But that's you.